Good morning and happy Tuesday to you. This is Jeff here. I'm coming with a lesson today. This is lesson 11 from the grade 7 unit 1 curriculum. We're talking now about some scale drawings, but we're going to kind of remove some information or make it seem like it's harder, but it really is not too bad. What I'm showing you here on this screen, this is a lunar lander from the, I want to say it was the Apollo 11 lunar lander. I'd have to check my sources to make sure, but this basically is a scale drawing of that. And you'll notice that on this particular scale drawing that the scale is outlined right here as a scale of 1 to 50. So you might wonder, what does that mean? As far as the scale is concerned, what we've seen up to this point is our scales have been including units. But right now, this scale does not include any units. So for example, if you were to measure a line on this scale, maybe say from here to here, right? From this distance to this distance, just trying to draw a little dimension here, okay? If you were to measure this particular distance, using your ruler, if you measured a distance of say 6 centimeters, okay? Well, what does that correspond to, or what would that mean in terms of real life? Well, with a scale of 1 to 50, that means that this drawing is actually 50 times smaller than what it is in real life. So a distance of 6 centimeters on a drawing, that would correspond to a 300 centimeter distance in real life, or 3 meters if you will. So this 1 to 50 scale would help us understand that any distance that we measure on here in real life is 50 times larger. Now, just to kind of go along with that, let's suppose I measured another distance on this drawing. And let's say I measured the distance from the top of this leg to the bottom of this foot, right? This landing portion here, okay? And let's say I measured this, and it turns out that this particular measurement is approximately 5, and you're going to wonder, what? Inches, okay? So let's say it's 5 inches. Now, again, this is the distance on the drawing, okay? So if it's 5 inches here, now you're going to say, well, wait a minute. How come up here I measured 6 centimeters and down here I'm measuring 5 inches? Why did I change the unit? Well, what I'm trying to show you here is that the scale having no units is actually very useful, because the distance that I measure here in inches would correspond to a distance of 250 inches in real life. So 250 inches, which translates to a little over 20 feet, would be our distance here. And again, this is, of course, assuming that what I'm measuring is true to size, okay? Now, it says the scale is 1 to 50, but here I am on a computer screen. Does this distance really correspond to 5 inches? I don't know. I'd have to print this scale drawing on a piece of paper true to size to see if this was the actual distance. I'm just trying to show you here that if I measure 5 inches on here, that would correspond to a 50 times larger distance based on this scale. So no matter what unit, let me type that out, no matter what unit used to measure, the 1 to 50 scale would correspond to a distance of the same unit, but 50 times larger, okay? So that's kind of what I'm saying here, okay? So now we're going to see some drawings, and we're going to sometimes not necessarily see a unit attached to the scale, but that's so you can use whatever measurement unit you're already utilizing. And also, it allows you to go between distances and understand that some scales, while some scales may have units attached to one or the other, sometimes there's no units or they're unitless scales, which allow you to assign what units you want to use. So let's take a look at another example here within this lesson. And now we're talking sort of some text. We'll draw a picture to go along with this as well. A rectangular parking lot is 120 feet long and 75 feet wide. So one student, Lynn, made a scale drawing of the parking lot that is a scale of 1 inch to 15 feet. The drawing she produced is 8 inches by 5 inches, okay? Whereas Diego made another scale drawing of the parking lot at a scale of 1 to 180. The drawing he produced is also 8 inches by 5 inches. How each scale would produce an 8 inch and 5 inch drawing. So you may look at this and say, well, how is it that this scale and this scale are producing the exact same drawing based on this? But let's take a look at how those are calculated and see if we can make a determination from that. So let me draw a rough rectangle. I gotta use my line tool because for some reason my polygon tool is not working. So if this is not straight, just forgive me. Okay, so let's go with this. And here's our rectangle. Okay, so this particular drawing is based on a real life distance of 120 feet long and 75 feet, right? So let's say this distance right here is 120. I'll use my text tool. Let's say this is 120, 120 feet. Okay, let's put that there. And then this is 75 feet. Okay, so now with 1 inch being 15 feet, we can figure out how long the drawings that Lynn would make based on this, right? So with a distance of 120 feet, well, even if I wanted to make like a double number line, I could do that to try to get down to why she has 8 inches as that, right? So what I mean by that is if you haven't seen a double number line, and again, there's a lot of strategies that you can utilize here. Let me change the color. There's a lot of strategies that you can utilize here, including ratio tables. You can use proportions if you're comfortable solving proportions and understand how they work. You're certainly welcome to do that. But I like the double number line just as a visual for ratio relationships, okay? So here's how you use this. Let me just kind of tick this off a little bit here. And I'm going to draw, actually, let's use a dash line so you can illustrate here. So this point here on the number line is the same here and here and here and so forth, and I'll get down to what or try to show you what is in a second what I'm trying to show you. This one here is fixed at this point. Why is that? No, it's not letting me change that one. So let's undo that and just draw it again. Here's what I mean by that. So here's the 4 points here now. Okay, so if my first number line is going to be my inches, and this is I'm using Lynn's scale here. My second number line is going to be the corresponding distance in feet. Okay. So with 1 inch here, that would correspond to a distance of 15 feet on this second number line, okay? So 1 and 15 would be the same quantity. Well, what would it be on my next line? It would be 2 here, right? 2 inches here, and what distance would that correspond to here on my feet number line? That would be 30, okay? So again, another 15 feet. So every time I go another interval on the second number line, I'm getting 15 more feet, right? So if for some reason I was looking at a distance of 45 feet on an actual drawing, on my scale that would correspond to 3 inches. And if I keep doing that, I would make a double number line, okay? I also could make what's called a ratio table. So I'm gonna just kind of draw this out here just to show you how I could illustrate this. Let's use my dashes, not my dashes here this time, and let's make a T-table. It's a little ratio table here. So my inches will be on the left, and my feet will be on the right. And again, same kind of concept here. I go 1, 2, 3, 4, 5, and I can obviously continue and go forth. And then here on my feet side, I've got 15. Every time I go to a new line, 15, 30, 45, 60, 75, right? Let me just keep going. 90, 115, 115, 105, 120, okay? And if I were to, let me just extend this a little bit further, 6, 7, and 8, right? That should pretty much right there cover why Lynn's drawing is going to be 8 inches by 5 inches, because look at the distances that she has to convert. 120 feet here on this ratio table corresponds to 8 inches on her drawing, whereas 75 feet corresponds to 5 inches on her drawing. So Lynn's drawing being 8 inches by 5 inches makes sense based on the scale that she's using. Okay, so that's sort of our scale that we used in previous lessons. Well, now Diego comes along and says, oh, no, we're going to go 1 to 180 as our scale. And now you're going, huh? Wait a minute. 1 to 180, but then still getting a scale of 8 inches to 5 inches. So let's figure out what's going on here. Okay, Diego is using a scale that's much larger in numbers, right? But what's going on with this scenario here, 1 inch to 15 feet? Whereas we're going 1 to 180. So we're using a unitless scale here, which means that whatever 1 is would correspond to 180 of the exact same thing. Okay, now watch this. Diego let's use this smaller number here just to show you what happened. 8 inches by 5 inches is the scale, is the drawing, that he ends up with. Okay, so let's use the 5 inches to kind of show you. If his drawing is 5 inches, right? I'm just doing it below the scale here, right? Corresponding from here to here. What would the number be here? Well, if every one is 180, 5 of them would be 180 times 5, which is 900. Okay, so once again, now you're going to say, well, wait, 900? 900 what? Well, if it's 5 inches on his drawing, that corresponds to a real-life distance of 900 inches. Okay, so 900 inches. Now let's see, okay, hold on. 900 inches. What real-life distance do you suppose that actually equals? Well, you could check it out with a calculator if you'd like, but here's a relation, right? 900 inches corresponds to what real-life distance? 75 feet. Do you think 75 feet would convert to 900 inches? Well, if you're not convinced, what's 75? Let's convert 75 feet to inches. 75 feet corresponds to 12 inches per 1 foot, right? So remember, if I convert units, I want to use the exact same measurement. Conversion factor, 12 inches and 1 foot are the exact same thing, right? 75 times 12, well, that's 75 times 10, which is 750, plus 75 times 2, that's 150. So 750 plus 150 is equal to 900. So check it out. Diego's scale makes sense because he's using an inch, or at least in this drawing here, he's using sort of an inch equivalence. Every 1 inch corresponds to 180 real life inches. Now let's look at it another way. Take a look at the 2 scales I highlighted here. I'll underline them again just so you can show you so I can show you what I'm showing here, right? 1 inch to 15 feet. Well, what if I converted this scale to inches instead? What's 15? Let's do the same way. 15 times 12. Well, 15 times 12 is 10 times 12, right? 10 times 12, which is 120, plus 5 times 12, that's 60. So 120 times 60, guess what it equals? It equals 180, okay? So that basically is showing you that these 2 scales are really the same thing, okay? And also explains why Diego and Lynn came up with the same drawing. Now, if you were to complete the following scale drawings here, make another scale drawing of the same parking lot at a scale of 1 inch to 20 feet and explain your reasoning. Express this scale without units. So let's try that real quick. If I were to do 1 inch to 20 feet, okay, that means that this drawing here, every 20 feet, you would have a 6-inch side here because 120 feet would correspond to 6 inches, and you can double number line that or you can ratio table it, absolutely. But then for the 75-foot spot, well, you know that you're going to be between 3 and 4. Again, if you use your double number line, you'll be between 3 and 4. You're going to end up with 3.75 inches, excuse me. So 6 inches by 3.75 inches. And then the last thing here is if you're going to convert this scale, 1 inch to 20 feet as a scale without units, you're going to want to change one of these numbers to be in the same unit. So 1 inch, obviously, you're not going to change that. But 20 feet, changing that to inches, 20 times 12 is going to be 240 inches, which means since the units are the exact same thing, we can say that this scale here is 1 to 240. Okay? So again, when we see a scale that's got no units, that just means that whatever measure we use on the left is going to be the same as the measure we use on the right. Okay, now last part for this video, let's go over and look at some of the practice problems from this particular lesson and start thinking about what we can use to explain these answers. With problem number 1, we have 3 scales, and our job is to figure out which one's the smallest to the largest, okay? The easiest way to do this is to express these in unitless ratios. So if I'm thinking 1 inch to 1 foot, what is the equivalence of 1 inch to a foot? Well, again, we just kind of saw that in the previous measurement, previous unit, lesson, excuse me, with the slide, 1 to 12, right? Because 1 inch and, 12 inches is the same as 1 foot. Well, now here in the problem 2 and 3, they're telling you how many yards there are in a meter, and they're also telling you how many centimeters there are in an inch, okay? So that means and also there's another thing you might want to know as well, how many yards there are in a meter, how many yards there are in, and also I'm not sure why they're telling you that now that I look at this, how this would work for you in here. So I'm going to give you a little tip, a little bit of a lead on this. 1 inch to 1 meter. Well, if there's 1.1 yards in a meter, right? That means that we can express this as 1 inch to 1.1 yards. Now follow me on this. This is going to be a little bit tricky. All right? I can express the scale like this. Now you're saying, well, how many feet is this? 1.1 yards. Well, again, how many feet is this? This is like, every yard is 3 feet. So this is like 3.3 feet. Again, not exact here on that, but just go with me on this, okay? 3.3 feet, right? So once again, now we're dealing with 1 inch to 3.3 feet, right? And now if I want to go to inches here, 3.3 times 12 inches, that's going to be approximately, that's on the top of my head, 39 inches or so, okay? Just about. So 1 inch to 39 inches, which means that this is 1 to 39, okay? So again, following the logic on that one's not easy, and I'm kind of giving you the answer to 2 and 3 in here. I'll let you kind of sort out which one is which here. 1 inch to 1 meter, 1 inch to 1 yard. So again, what it's saying is, what's the scale drawings from smallest to largest? If you were to draw in these 3 scales, which one would be the largest drawing, okay? Well, which one is the closest to the real life distance, okay? Here's a hint. 1 to 12 is the largest one, will be the largest one, okay? I'll let you decide between 2 and 3 which one is going to be the smaller of the 2. Okay, problem number 2. Which scales are equivalent to 1 inch to 1 foot? Now, to help you out with this, I'm going to once again give you a unitless scale for 1 inch to 1 foot. It's the same as the one we used in the lesson. 1 inch corresponds to 12 inches because, again, 1 foot is the same as 12 inches, which means that the scale, the unitless scale, is 1 to 12. Okay, so that already kind of gives you away as to which one is certainly going to be part of the answer. It's A. 1 to 12 is the same thing. Okay, and basically what you're looking for with the other 5 scales is you're looking for the second number to be 12 times the size of the first number. All right, so if you look at B through F, any of these ratios where the second number is 12 times the size of the first number. Okay, and that should give you the rest of the answers just using that principle. With the rest of the problems, there's actually a pretty extensive list of problems in section 11, which is okay. With problem 3, model airplane is built at a scale of 1 to 72. If the model plane is 8 inches long, how many feet long is the actual airplane? Well, if the scale is 1 to 72, remember this is a real scale, right? This is a unitless scale. So every inch, if you want to use inches, would correspond to 72 real life inches, okay? You may want to, for this problem, convert your scale to feet. In other words, 1 inch is 72 inches. You may say to yourself, well, how many feet is that? Okay, keeping in mind that there's 12 inches in 1 foot. Okay, so maybe write the scale instead of inches, convert these inches to feet, and maybe that will help you answer this question here. All right, with problem 4, now we're going back to an old lesson. Okay. Quadrilateral A is 3669. Quadrilateral B is a scale copy with a side length equal to 2. Jada says since the side lengths go down by 1 in the scaling, the perimeter goes down by 4 in total. Do you agree with Jada? Okay. Now, the shortest side being 2, you may consider yourself, what's the scale factor? Well, if this side length goes down by 1, that means that we're thinking dividing 3 by what to get 2, or you're thinking 3 times what is equal to 2. Well, in this case, the fraction here is 2/3. Okay, so not an easy scale, but 2/3 is the scale, 3 to 2. So if you're going from 6 down by 2/3, that's going to be 4, and then 9, you're going to go down by 2/3, that's going to be 6. So the perimeter, Jade is saying the perimeter would go down by 4 because every side would decrease by 1. Well, I just told you 6, 6, and 9, these don't scale down to exactly 1 less like this one. Okay, so would the perimeter go down by the same? And if you're confused about that, try scaling down and calculating the perimeter of the new shape and see if it's the same or 4 less than the perimeter of this shape. Okay. For problem 5, this is a lesson that's optional, and so some teachers may have skipped this particular problem, but I'll give you the quick answer here. Polygon B is scale copy of A using a scale factor of 5. Polygon A's area is what fraction of polygon B's area? Well, when you scale area, it doesn't work as the same as scaling distance. So in fact, a scale factor of 5 would mean that polygon B's area is 25 times as big, because you would actually multiply the scale factor by itself to get the area equivalence. And again, you know we did not do a lesson on this, so if that sounds foreign to you, it's understandable if your teacher skipped the lesson as well. So you would end up with a 25 times bigger shape for B to A. So since it's asking what fraction of that, you would just flip that number over. The answer is 1 over 25. Okay? And then lastly, figures R, S, and T are all scale copies of each other. S is a scale copy of R using a scale factor of 3. Figure T is a scale copy of S using a scale factor of 2. What are the scale factors for each of the following? Okay, this you may, to help you here, you may want to go ahead and sketch this out as well. Okay, if you use a scale factor of 3 to get from S to R, it means R is going to be 3 times as large. And then if you scale T using a scale T to get from a scale S, figure S, excuse me, and you scale figure S to get figure T using a scale factor of 2. That means S is going to be twice as big, okay? So for all of these, you may want to perhaps start with a figure S and then scale it using a scale factor of 3, scale factor of 2 to kind of help you answer these questions. Give yourself a visual, okay, to go with that. Anyway, hope this lesson video helped you. Remember these problems if you're in my actual class. Remember, we want to have these problems in by tomorrow. I encourage you to email your questions to me. You have my email both on the website and also on your syllabus. Hope you have a wonderful day. Don't forget to be awesome.